Connected Multimodal Mobility, headquartered at Clemson University. We are very fortunate to have Professor Mitch Shue among us today. Mitch Shue is a professor of practice in the School of Computing at Clemson University, leaving a long career in industry to join the Clemson faculty in 2019. Professor Shue holds a bachelor's degree in computer science from Trinity University in Texas and a master's degree from George Mason University in Virginia. Previously, he was Chief Technology Officer for Hello Wallet, a company specialized in web and mobile financial wellness programs, which Morningstar purchased in 2014. Professor Shue previously held leadership roles with Centrifuge Systems, Webs.com, Web Methods, and Transaction Network Services. He has helped grow 3 startups into strong publicly traded companies and 2 others into successful acquisitions. Prior to Clemson, Professor Shue served as Chief Technology Officer for Morningstar, a leading global provider of independent investment research and data, and was responsible for the company's technology vision and execution strategy. So as you can see, he has a very stellar record in the industry. Now he moved to Clemson, and we are actually collaborating. Our center is collaborating with Dr. Shue in a project, and we'll see some results from that project as well at the end of his presentation. So Dr. Shue, welcome to C2M2.
Thank you, Dr. Chaudhry, and thank you all for taking the time today to catch up on the state of cloud computing and its readiness for connected mobility applications. This is what I'll cover today in the next 35 to 40 minutes or so. To many, perhaps even many of you, cloud computing is a bit of a mystery, and there are plenty of misconceptions. Even to traditional IT professionals, cloud computing can be somewhat disorienting. So my goal today is to help you better understand what cloud computing is, its level of maturity, and its readiness for real-time connected vehicle applications. I expect that we'll have plenty of time for questions at the end of my presentation today. So what is cloud computing? Well, regardless of the cloud computing service provider, cloud computing is simply the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So when I say IT resources, think about resources used for computing, like servers or storage, networks, databases, etc. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So more on this in a bit. The leading cloud computing service providers today are Amazon Web Services, AWS, Microsoft Azure, and the Google Cloud Platform, often referred to as GCP. Now, I do talk a lot about AWS because it is the provider that I am most familiar with professionally. I'm also an AWS accredited educator for cloud architecture, but I won't spend all my time talking about AWS, but I wanted to make that clear. Also, when we talk about cloud computing, you'll often hear the term web services all the time. So what are web services? Software or IT resources that are made available over the internet are web services. So they're building blocks. They can be assembled to create innovative solutions to difficult problems. And like building blocks, web services can come in all different sizes and shapes and are used for many different functions. So For example, Gmail is a web service. So is a web-based API call to get today's weather forecast for your mobile app. You would use Amazon Web Services to start a server in the cloud. So innovation really comes from the creative assembly of these services rather than from the actual invention of these services. Now, before we continue, let me share some current market research on cloud computing. AWS introduced public cloud infrastructure only about 15 years ago or so. So these numbers are staggering, in my opinion. 90% of organizations surveyed by 451 Research recently already use cloud computing in some way. Even if only for data backup or disaster recovery, organizations are definitely making the move to the cloud. According to a recent Forbes survey, 83% of enterprise workloads will be processed in the cloud by the end of this year, which is pretty astonishing. There are always questions about security in the cloud, but a recent Salesforce survey revealed that 94% of the survey participants actually realized improvements in security after moving to the cloud. As Dr. Chaudhry said, I was the CTO at Morningstar, which is a global leader in independent investment research and data, and security was paramount to me, and the key factor in our decision to begin our cloud migration back in 2016. Cloud global spending will reach over $330 billion by 2022, according to Gartner. And the market valuation of the companies that are part of the global cloud computing market will reach over $620 billion by 2023. AWS, as I mentioned earlier, is the current leader in cloud computing services with about 1/3 of the market and annual revenues of $35 billion. And that's just for the Amazon Web Services part of Amazon's business. Does not include any of their retail revenue. So $35 billion a year for their cloud computing business. So why is all this happening? Well, for most organizations, running data centers is not a business differentiator. And cloud computing is now mature enough to provide a truly viable option for them. So here are typical questions I hear from industry decision makers, researchers, and students. How does cloud computing compare to traditional computing models? What are some of the advantages of cloud computing? Is it reliable? Is it secure? Is it fast? Is it cost effective? These are typical questions that I hear repeatedly. So let me address these over the next few slides. Okay, with traditional data centers, you think of infrastructure as hardware. You buy servers, storage, network equipment, etc. So infrastructure is a capital expense. You make educated guesses about the computing capacity you need for your business, and you purchase the equipment, so there's this upfront cost, and then you wait for the equipment to be delivered, and then you configure, connect, and operate it. With cloud computing, you think of infrastructure as software. You think of infrastructure as disposable. It's a very different mindset. And there's no upfront capital expense. you essentially trade capital expense for variable expense, and you pay only for what you use. So you no longer have to guess your computing capacity needs. You can change your capacity whenever you want, and you don't have to wait for equipment. So your organization can move much faster. There are several cloud deployment models available. So more traditional, long-standing companies rely on their own private data centers, and they extend their capacity using virtualization or containerization technology to get the most out of their hardware. Others will use a hybrid approach, executing some workloads in their private data centers and others in the cloud. And this is the way Morningstar operates. Morningstar is in the middle of a multi-year cloud transformation, moving out of 8 global data centers, and I think 4 or 5 have already been shut down. I checked recently with my former colleague there, who's a senior cloud architect. So the commitment that I made when I was the CTO was to reduce our owned hardware infrastructure by 70% over the next 5 years. So we're about 3 or 4 years into it, and have shut down 5 of the 8 data centers. Some organizations use public cloud infrastructure exclusively to meet their business needs, and this is true for most new organizations. I mean, there's rarely a need to actually buy your own equipment anymore. So the point here is that organizations have many deployment options and can operate in a way that makes the most sense for their businesses. Now, if cloud computing concepts and terminology were too novel, it would be difficult for traditional IT professionals to commit to cloud transformations. But fortunately, traditional IT concepts map to cloud computing concepts in very familiar ways, regardless of the cloud service provider. So for example, here's a mapping of traditional IT concepts and terminology to AWS concepts and terminology. So this makes it easy to have meaningful discussions about transforming traditional data centers to use cloud computing without having to learn a whole bunch of new concepts or terms. So I described cloud computing as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So you can see what I mean here. So instead of buying on-premises servers for a traditional private data center, I can rent the compute capacity in the cloud. In AWS, server instances are known as EC2 instances, and they come in a wide variety of shapes and sizes. And so the same is true for security, storage, network, and database resources. So again, very familiar concepts and a clear mapping between traditional and cloud computing resources. So what are some of the advantages of cloud computing? I touched on some of these earlier, but it all bears repeating. Big advantage, trade capital expense for variable expense. That is, pay only for what you use. And this is like the public utility model of pricing. AWS, Microsoft Azure, Google Cloud Platform pass savings on to customers as the cost of their own infrastructure goes down. So you as a customer benefit from massive economies of scale. AWS has reduced prices over 70 times since introduction in 2006. Another advantage is that you can stop guessing capacity. Guessing capacity is important when you buy equipment, but not important in the cloud, because you can adjust your capacity whenever you want to meet the current and changing needs of your organization. I mean, if you buy equipment, you own it. If you buy if you under provision equipment, you're stuck with it. If you're over provision equipment, you have a lot of waste there. So it's a big advantage to stop guessing capacity. There's usually some time that elapses between when you buy equipment and when that equipment is received and ready for use. This can be weeks, sometimes even months. With cloud computing, this can be literally minutes. For most organizations, as I said, running data centers is not a business differentiator, but it is a huge expense in equipment and people. Today, cloud computing provides a viable option for organizations to get out of the data center business. Because of the vast infrastructure provided by the leading cloud service providers, organizations can extend their global reach almost instantly. Okay, but is cloud computing reliable? Well, reliability is one of the keys to running enterprise applications successfully in the cloud. It's certainly a requirement for a real-time connected vehicle application. So this is how AWS describes reliability. So fundamentally, reliable systems must be able to recover from infrastructure failures. They have to scale automatically to meet demand, and they have to be able to ride through transient disruptions. So this is what cloud providers offer to guard against inevitable failures. So all cloud providers offer infrastructure and network component redundancy, auto scaling or automatic scaling features to handle sudden or gradual increases in demand without having to change the architectural design of your application. And they offer well understood best practices and automation features to ensure rapid recoverability. In case you had any questions about data loss, here's a stunning example of Amazon S3 and the data durability commitment of Amazon S3. So if you store 10 million objects using Amazon S3, which is their object storage service, you can expect to incur a loss of a single object once every 10,000 years on average. So that's an example of pretty good data durability, I'd say. And that's just one example. Of course, durability is just one measure, but it's pretty astonishing that they can make that kind of a claim. Is cloud computing secure? My biggest question as Chief Technology Officer at Morningstar was security in and of the cloud. Security must be a first thought, not an afterthought. Moreover, security protections must evolve to meet the increasingly sophisticated nature of modern cyber attacks. And this, of course, is critical, especially for real-time connected vehicle applications. So cloud providers offer the following security controls. Now, keep in mind that it's not completely up to the cloud providers to secure your application. You have a part to play as well. But this is what they offer. A strong identity foundation, which is a key to strong access control. The principle of least privilege you may have heard of, which is essentially granting users and services the minimum access they need to do their job. That principle can be implemented if you have great identity features, if you have a solid identity foundation. Auditing controls are key to accountability, anomaly detection, and forensic analysis. Fine-grained security controls at all layers, often not available in most data centers. This fine granularity enables modern defense in depth measures. Previously, the focus of security has been on securing the perimeter of systems, and that is keeping bad guys out. But modern security approaches are zero trust, and that is they don't assume that just because you have found your way into the house that you are allowed to wander around anywhere in the house. So there's a principle of zero trust in defense in depth. So security controls placed well within your application can help with that. Providers also offer rich automation features to reduce the chance of human error and strong protection for data at rest, in transit, and in use. Is cloud computing fast? Yeah, we've talked about reliability and security. What about performance? It's fast. Unlike traditional infrastructure, think hardware, cloud computing allows you to choose and dynamically change your resource capacity to meet the demands of your organization. So you might not even truly need servers, even cloud-based servers. So all providers now offer serverless computing, where the cloud provider actually takes care of all the underlying infrastructure and you focus only on your code. And if you do need servers, there are many, many options for you. For example, Amazon EC2, which is their compute resource, provides some 275 different choices of servers to meet the demands of highly diverse workloads. So different operating systems, different compute capacity optimized for compute, storage, memory, network, your choice. And again, you can change that out at any time. So you can start small and scale up and out. Is it cost effective? Well, with pay-as-you-go pricing and no upfront costs, it is usually very cost effective. But here are some things to consider. The three factors that determine pricing the most are compute, storage, and data transfer. So you need to make sure that you have alerts in place to catch resources that may be running away. And it's just good practice to monitor your application using built-in monitoring features that all cloud providers provide so that you can understand how your application is actually working. Sometimes organizations build in too many high availability features, and that can really add to the costs. That's like having too much life insurance. So, you're paying these enormous premiums for coverage that you probably don't need. So that's something to consider. Also, there are possibly duplicative costs while in transition from a traditional data center to cloud computing. So again, going back to my experiences at Morningstar, we had many products that we were serving out of our own data centers. And as we transitioned to the cloud, we were incurring cloud computing costs, but at the same time, we were still paying for our private data center resources, as we had to keep those products running as well. So there is this period of time when you're transitioning where you may bear duplicative costs. Finally, are you optimized for the cloud? If simply lifted and shifted an application from a traditional data center to the cloud, you're not leveraging modern services. Or if your mindset has always been around servers and databases and sort of client server architectures, you may be paying more than you need. For example, at Morningstar, we took an application. It was a very traditional application, and we moved it to the cloud, and then we optimized it. We looked at it and we said, we don't actually need servers because this application just doesn't need servers. And it only runs 46 hours a day, so we don't have to have the application actually running 24 hours a day. And the components it was using for database, very expensive. So we shifted away from that. So through this process of optimizing, we actually reduced the cost of that application by a staggering 97% by optimizing it for the cloud and going serverless. So there are so many services that you can leverage once you're in the cloud that are just not available in the traditional private data center. So very possible to optimize for the cloud by leveraging those modern services. All right, we've talked mostly about cloud computing infrastructure services, but the leading cloud service providers have advanced well beyond infrastructure. So for example, here are the AWS service categories. So new services in the areas of IoT, AI and machine learning, augmented reality, virtual reality. They've all given rise to innovative solutions in all problem areas, including those found in smart city and connected vehicle applications. And again, innovation comes from the creative assembly of a wide array of web services to create powerful solutions. So it's no longer about inventing these services, it's about assembling them in innovative ways. Okay, so here's the question of the day. Is the cloud ready for real-time connected vehicle applications? AWS recognized the need to jumpstart connected vehicle applications and created the AWS Connected Vehicle Solution. And it combines web services from across the AWS service catalog, from IoT services to real-time data streaming to serverless computing to notifications. This targeted solution frees developers to focus on their specific applications rather than on the underlying infrastructure or foundational architecture. So through automation, developers can easily recreate this environment with a click of a button by using an AWS CloudFormation template, which describes the environment in human readable code. And the same templating feature exists for Google Cloud Platform through the Google Deployment Manager templates, and then in Microsoft Azure also using the Azure Resource Manager templates. So recreating environments automatically from code templates eliminates the possibility of human error. Similar in spirit to the AWS connected vehicle solution, the Microsoft connected vehicle platform provides consistent foundational architecture for building real-time connected vehicle applications. It also leverages and integrates a wide array of web services to get developers started quickly. Of the three leading cloud computing service providers, AWS boasts the most automotive customers. Now, they're not all focused on connected vehicle solutions, but many are. And these are easily recognizable and reputable brands, which gives other companies plenty of cover when they decide to move to cloud computing. Just like back in 2016, I had an opportunity to speak to several thousand people at an AWS conference and publicly stated our commitment to reduce our infrastructure by 70%. And after that actually gave a lot of financial services companies some cover. They could basically say, Morningstar CTO said they're doing this, so I guess it's okay. So that's one example of how these automotive customers can really affect commitments from other people as well. Let's see, Jason in the chat, you want me to go back? Is that good?
And also I'd like to mention one thing. So this is being recorded, so it will be available on our website and on our YouTube channel. So this presentation is being recorded. So in a day or two, it will be online. Go to our C2M2 YouTube channel. There will be a link from our C2M2 website.
All right. Volkswagen announced a partnership with Microsoft to build the Volkswagen Automotive Cloud to create a seamless and rich experience for drivers. So as you can see, automotive companies are having to become software companies to be competitive and relevant going forward. Last year, Ford Motor Company acquired Autonomic and partnered with AWS to collaborate on Ford's Transportation Mobility Cloud. And the Transportation Mobility Cloud will be an open source platform that will help to connect cities and vehicles together. MyoVision was started by some folks at the University of Waterloo and has evolved into a leading authority on traffic data. And they help to build smart cities by transforming the way traffic managers or traffic networks are managed today. So they use AWS to process petabytes of real-time video and sensor data. Their work has made it possible for cities to improve their transportation experience for drivers, cyclists, and pedestrians. Finally, here at Clemson, we wanted to assess for ourselves the feasibility of using cloud computing for a real-time connected vehicle application. And actually, Stephen and Sabir, I think you're still on this call. So they are driving this research. We deployed a real-time optimization-based speed advisory algorithm in the AWS cloud to reduce a vehicle's stopped delay at an intersection and to improve its fuel consumption. So using signal and vehicle telemetry information. The application tells the vehicle or driver what speed to maintain in order to reduce the stop delay at an approaching intersection. So we gathered data from vehicles and signals along Perimeter Road, which is a road that runs alongside Clemson's main campus. And we also simulated the data and conducted a field test. And the speed advisory information that's returned to the vehicle reduced the intersection stop delay by 96% by optimizing the driving speed as the vehicle approached signaled intersections. Now we tested the round trip time for messages between AWS and the connected vehicle, and it was consistently less than 200 milliseconds. Of course, this is important because the speed advisory information is useful for only a very short period of time. So measuring and factoring in cloud delays was essential for this research. We did use key elements of the AWS connected vehicle solution architecture for our proof of concept, but not the entire solution architecture. And the project raised many interesting questions for future research. So cloud computing is sufficiently advanced and robust enough to handle the high availability and performance demands of real-time connected vehicle applications today. And as these demands become more sophisticated, I'm confident that the leading cloud computing service providers will rise to the challenge as they already have. So I think that that concludes my prepared presentation, and I hope I've helped you to learn about or fill in the gaps around what cloud computing is, the current state of the market, how it's different from traditional computing models, how cloud computing reliability, security, and performance stack up, and its suitability for real-time applications like those for connected mobility. So thank you for your time, and I'm happy to take any questions, comments that you might have.
So, Mitch, so they're writing in the chat. So there are a few questions already there. So if you want to address them one by one.
From Anurag, do you know, relatively speaking, which state DOTs are forging ahead with cloud computing, if any? I don't think I can answer that question. Dr. Chaudhry, do you?
Yeah, so I know, so Berkeley, so Caltrans, California Department of Transportation, they are working with cloud computing, Amazon Cloud, for real-time traffic management. So, yeah. So my former student, Saqib, who is at Berkeley now, is working on a project where they're using cloud computing, right? So, yeah. This is a Caltrans project. So that's all I know, that for real-time application, so probably not many states are working on it. So I'm only aware of California.
Okay, another question is there an industry rule of thumb when to use local servers or cloud services, or is it better to depend on cloud services from the beginning? I think some of that depends on the situation. If you have an existing application that's running in your data center, and it's really not a business differentiator for you, and there's no specific reason to run it locally, it would be a good idea to consider cloud services, especially if you can optimize the application using some modern services that are not available locally. So for example, I mentioned serverless computing. All the platforms offer serverless computing, and it's a good way to sort of re-architect your application to not depend upon sort of traditional resources and things like that. And again, there's so many resources and web services available to assemble in ways that you couldn't do locally. So there's not really a rule of thumb. I can't really think of too many reasons why you would necessarily want to run anything locally. Obviously, if you have some extreme performance requirements where maybe your data source is also in your data center and you can't afford any network latency. There's obviously some edge conditions, but I think it would be good to certainly look at cloud services. And if I was developing something from scratch, I would definitely go cloud first, for sure. How is the cloud more secure than private data centers? Okay, I can speak directly to this for sure. As I said, Morningstar had 8 global data centers when I became the CTO, all over the world. And our attack surface was pretty big. And some of it was because being a long-standing company, we created a lot of interesting complexities by stitching together products, integrating acquisitions, things like that. So it was interesting. Our product offering, just in our own data centers, just becoming increasingly more challenging to secure. And as I mentioned, in the cloud, you have a lot of fine-grained security controls that you don't typically have in a traditional data center. So for example, in AWS, if you're using server instances, EC2 instances, you have the ability to essentially configure a virtual firewall for each instance. You have the ability to put those instances into your own private network in your own configurable network segments, and you have network access control between network segments. You have so many different ways to secure your applications in depth rather than just at the perimeter. So we made the assessment that we could secure our applications at least as well in the cloud, if not better, than we could in our own private data centers. Now that wasn't the case just a few years ago. So it is definitely, hats off to all these cloud providers who realized that security was the biggest question that a lot of people had. So I definitely believe that you can secure your application in the cloud at least as well as you could in your private data center. More likely, you could secure it better in the cloud. Let's see. What is your opinion about cloud architecture for computationally intensive machine learning vehicle to infrastructure applications? Would a serverless architecture be sufficient, or would we need a server-based architecture? Yeah, I think that that's a nice thing. That really hits one of the key points about cloud computing is it encourages experimentation, right? And you don't have to make a lot of upfront decisions. You can sort of try things, right? You can say, well, I'm going to try using a traditional server-based approach, and I'm going to provision a super capable server instance with GPU support or whatever, and I'm gonna use that for training or whatever. And if it you come to find that that's not the right thing to do, you can pick a different instance, or you can try to do something serverless. And since you're paying as you go, it really encourages a lot of experimentation because unlike traditional data centers, you can make changes quickly. There are not a lot of upfront costs, if any. And so I think there's different approaches. Certainly for our research at Clemson, this project that I just talked about, Stephen and Sabir, the students working on this, went serverless. They, I think, originally thought naturally that they would do what they knew how to do, which was write applications and deploy them on servers. I think they realized pretty quickly that they could create a more robust architecture by going serverless and then introducing other web service components to decouple dependencies and make the overall system more extensible. So I think you should just experiment. I don't see any other questions in the chat at the moment.
So, Mitch, so I would just like to add one comment because
Sure.
we are working on application of cloud computing for connected autonomous vehicle applications.
Yeah.
So one of the major issues we are trying to evaluate is the processing times. If you send some information from vehicles, what is the upload time, download time, plus the processing time? So Mitch mentioned a couple of the companies like Mahavision and other companies. So we did have collaboration earlier with some of these companies. So one thing that we wanted to evaluate, because those companies are saying that, okay, the time could be 1 minute, or which is not good for real-time application, like safety application. So we are trying to see that really we are trying to reach the cloud at different time of the day, because the demand on the cloud is different by different time. So I'm looking at the real-time application. Is it feasible? If it is at a millisecond level, then we are fine. So far we found that, yeah, it's very feasible, because the delay was millisecond, the upload time, download time, plus processing time in the cloud.
Right. And all the cloud providers are also continuing to enhance their edge computing, their IoT offerings, and really permitting a lot of computing and processing to be done, at the edge, in addition to computing, directly in the cloud. So I think these cloud providers are continuing their pace of innovation, because these sorts of applications demand it. Yeah, I thought it was pretty interesting what Stephen and Sabir did to test the latency at different times of day in different parts of the world, at least on the AWS compute infrastructure. I think it would be interesting to see if their round trip times would hold up consistently in Microsoft Azure or Google Cloud Platform even. I think that would be certainly an interesting follow-on study.
We are also looking at the security aspect of cloud computing. So with Dr. Mitch Shue, so that's our ongoing project, the security.
Yeah, security, AWS is fond of saying that security is job zero, which means, security above everything. And that's why you look at all the identity foundations for Microsoft Azure, AWS, Google Cloud Platform. I mean, that's just the key. is to figure out, you know, how to properly grant access, but then also how to secure resources, you know, at all layers of your application. And I think all of them have done a great job of sort of reducing the questions about security or eliminating them entirely.
Yeah, I think on the DOT side, when I recommend DOTs to use cloud, sometimes they're reluctant with the idea because they think it's managed by a commercial provider. So they are more comfortable when the data processing is in their own computer, the computers they own. So relying on some commercial provider, sometimes they're very reluctant. They don't know what is going on in the commercial.
Sure, we faced that when I committed Morningstar to a cloud transformation. We had great people running those data centers at Morningstar. I mean, fantastic people. But the world's changing, and like I said, you know, for most businesses, running a data center is just not a differentiator. I mean, for example, at Morningstar, no one bought Morningstar's financial services products or data because we ran our own data centers. I mean, it just doesn't make sense, right? So the world is changing, and you know, you saw that list of automotive companies that have committed to AWS. There's not as many, but there are many that have committed to the other cloud platforms as well. And then you look at you know, companies that rely their businesses rely entirely on cloud computing, whether it's you know, somebody like a Netflix or even Zoom. Zoom has their own computing infrastructure, but they have also made a huge commitment to running a lot of their processing through the cloud. So there's certainly lots of room to run in a hybrid fashion, which is what a lot of companies do. They leverage the strengths of their traditional IT private data centers as well as the cloud. But I'll tell you, the innovation, the pace of innovation in the cloud is pretty astonishing.
Thank you, Dr. Shue. Yeah.
Thank you. Thanks very much for your support. I guess we just have a couple of minutes. I don't see any other questions, but I'm happy to connect with any of you offline. You can find me on LinkedIn or at my Clemson email address on the screen as well.
Thank you all. Thank you for attending the C2M2 webinar Distinguished Speaker series.